This is these are the stars that we'd see in the early evening as we show them in our Griffith Observatory magazine. For a long time now, we've been showing Saturn as soon as it gets dark, but this is the last couple weeks that we'll really be able to do that. Saturn is moving behind the sun from our point of view, so we see it low in the southwest sky after dark, but for a shorter and shorter time. By next week, it'll be 10:30 or so that it will set. So Saturn, nevertheless, is still a beautiful object to look at, and I like showcasing recent amateur astronomers' efforts of photographing the planet. These are usually done by taking videos and then using a computer to stack thousands of frames taken over a few brief minutes together, and it averages out to make an exceptionally sharp view. Uranus and Neptune are both up. Both of them are easily visible with a telescope, but the challenge is you have to know where to look. And I expect you to memorize these charts. No, actually, the Neptune actually comes up first. It's at opposition right now. That means it's up all night long. It's opposite the sun in the sky. It's only 3 billion miles away, about the same distance as Pluto, but nevertheless, you can see it in just about any telescope. A couple hours later, Uranus also is visible. It can be seen with binoculars quite easily. But if you go to the Sky Report, which I put out every week, there are links to where you can find charts and stuff if you want to try hunting these down. And just to show you what people see on it, this is what Voyager 2 saw when it got to Uranus. And it actually was a little bit disappointing because people had been sketching details on it. People, quite reputable, very skilled amateur astronomers had sketched bands and things on it, but Voyager saw very little evidence of anything like that on the planet. But apparently that changes, and we can go to pictures taken within the last couple of weeks. Well, this is a sketch, so you either believe it or you don't. But there is some evidence backing up this. You can see some faint bands. The way Uranus is tilted in the sky, its north pole is pointed down this way. So, it has an unusual orientation. Now, these are actually stacked photographs, and they show what Voyager wasn't able to see, maybe just because of timing, that in fact there are lots of belts and things now active on Uranus.
Photographs from Earth?
These are photographs from Earth. This is with an 8-inch telescope.
Is that the rotational axis or just poles?
Yeah, this is showing, this is the rotational axis. Okay. This is its orientation in the sky. So north is the direction in the sky. Its north pole, however, is pointing out in this direction. You can see how that corresponds to the photograph. And then Neptune. Now, Neptune did show more detail from Voyager 2, and it is very, very hard to see any of it from Earth with any telescope, partly because Neptune is so faint. You need a telescope to see it. It looks like a faint star. If you have a telescope like ours at Griffith Observatory, you can get enough magnification to see it as a disk, but it looks very, very dim. It looks like a ghostly blue, almost like a planetary nebula, like we were talking about earlier. So very few people have actually recorded seeing details until recently. And actually, Neptune apparently has been having a lot of storms on it recently. We can go to an image again taken this month, a series of images taken in one night, and we can see some large storms. These are not through any exotic filters. These are actually kind of invisible wavelengths, so they do show there are bright and dark clouds going on right now. And unless you think this might be some kind of artifact in the camera, this Russian amateur astronomer actually put his observations together into a short movie, which you can see. Now, Neptune takes 16 hours to rotate, and so in a night you can only get a fraction of that. But you can see there really are details there. I should just mention there's interest now, again, Jet Propulsion Laboratory is trying to put together proposals for possible spacecraft to either Uranus or Neptune or both, some kind of small orbiter to figure out more what's going on there. We really don't know much about those planets. another big event this month that happens once a year is the beginning of autumn. And that will take place on, drum roll, September 23rd. So be up at 1:21 in the morning and you can see autumn start. Well, no, actually you won't see it start.
See
then.
autumn start.
But if you're,
All the leaves will just drop
right.
off the trees.
but if you get up about 7 in the morning, you can see the sun rise directly in the east. Around 1 in the afternoon, it crosses the meridian. It's noon because we're on daylight saving time still. And then around 7 in the evening, it sets. And of course, we'll have a big event. Well, kind of a small event, but but
An event nonetheless.
We do have an instrument on the west side of the building which actually shows two aspects of this. It shows the height of the sun when it crosses the noon meridian, and we also have markings in the lawn that show, not in the lawn, but in the
terrace.
concrete walkways that show when the sun sets directly west, and that's something we like pointing out every season.
And make sure the lines are lined up. The sun needs to set directly on that line or else something's wrong.
That's right.
During the day, though, the path is along the celestial equator.
You know, it's not on the celestial equator. Well, I'm sorry, it is. On that day it is.
That day.
And yeah, and
Okay.
and every day after that until the beginning of spring, it's below the celestial equator. And then in the summer and until autumn again, it's north of the celestial equator. Okay, anyway. And then all those planets that were bright in the evening sky until last month are now in the morning sky. So if you get up early on September 10th, we look off to the east. Before sunrise, you'll see the moon. Right above it will be a really bright object, and you'll see another couple other objects, Venus, Mars, and Jupiter. All of these objects will move, well, not Venus. Venus will be visible in the morning sky for about 4 months. Now I'm getting mixed up. Not 8 months, and then loop around to the evening sky again late in 2016.
So
Mars-
next Thursday morning,
Yeah.
get up early.
Yeah.
Because that looks cool.
Yeah, and also this month we're beginning to see them in October. There'll be all kinds of clusterings of these planets that'll be really neat, but you can get started on the 10th. And then finally the eclipse, and just to point out a couple unusual things about this, as Dr. Danley mentioned, the moon will be in eclipse when it rises. Now, because the Earth is between the moon and the sun, that means that as the sun sets, the moon will be rising exactly opposite. So if you have a mirror or something, you can watch the sunset, and right next to it, you'll see the moon rise. Our horizon is not perfect. Here in LA, we're looking out towards San Bernardino, and this is Tockwitz Peak, which is like 7,000 feet high, but it's also 87 miles away, so it looks like a little bump on the horizon. But that can hide the moon for several minutes compared to if the horizon was absolutely flat. Also, the sun is lighting the sky, so the sky is going to be bright. And this diagram kind of shows how the sky darkens as the eclipse progresses. So when the eclipse becomes total, the sky will still be a little bit bright, but it will darken completely before totality is over. So we'll get a good look at this eclipse, and then it'll end when the moon's about 45 degrees up.